So thank you for staying for the last session of the day. It's been a very long day full of very serious talks. So let me introduce myself. I am Evelina Gabasova. I work in the Alan Turing Institute in London, which is the British National Institute for Data Science and Artificial Intelligence. And I work there as a data scientist. And that's normal serious work. But outside of that, I like to play with actual interesting data. I'm pretty sure that's the name they are going to use for the next movie. So this is the first time you have seen it. So let's talk about Star Wars. Who loves Star Wars? Well, I certainly do. So when I was thinking, so as a data scientist, what kind of data can I actually analyze around Star Wars? Well, of course, there are the movies, but that's kind of like movies, you can't really stick them into R or something and do something cool with that. And then I realized that all movies have scripts, screenplays, and you can actually get them online. And there are a couple of websites that publish scripts. I'm not sure what's the legal standing of them, but actually the scripts appear there usually very often, like very quickly after the movie comes out. I was actually really disappointed that the script of The Last Jedi didn't appear there yet. So my whole analysis doesn't include the latest film. So I actually download the script, and if you look at a script, it has a very nice standardized format. All scenes start with int or ext, meaning interior or exterior. Then there is the name of the scene, there is some description, and then there are the people speaking. And their names are always in bold capitals in the center. That's pretty easy, right? And I thought, OK, so what can I do with this? Well, I can parse the scenes. I can get the people talking in each scene. And then maybe I can even construct a social network by looking at characters that speak together in a scene. And then I would get a social network of the whole Star Wars universe. Sounds pretty easy, right? So I looked at the scripts as they were published online. And they were really nice HTML, pre-formatted blocks of text with, as I said, the scenes in bold capitals here and names in bold capitals. That's easy. So I wrote a parser for that. I ran it on all the scripts, and it didn't work. Because obviously, in data science, 90% of the work is data wrangling, and 10% is complaining about data wrangling. So let me complain a little. I ran my program on all the scripts. And for example, episode 3 of the prequels came up with this script. And suddenly, the names of the characters were in bold capitals again, but they were followed by a colon, and then what the characters were speaking. So that's not very helpful. I wrote another parser, another set of regular expressions, and it didn't work either. So I looked at some of the names. And for example, here, the second character is not uppercase I. It's a lowercase l. That's this scary guy, by the way. Yeah. So I rewrote the parser again, ran it again with a lot of exceptions for the characters that didn't quite fit in. And then, well, I looked at the resulting networks, and something just wasn't right. Because some of the crucial characters were missing, like R2-D2 or Chewbacca. So I thought, OK, what's happening there? Like, why did my algorithm miss it? So I looked into the scripts, and they contain things like R2 frantically beeps something. That's not very helpful. And Chewbacca barks a command, and Han says, boy, you said it, Chewie. No, you didn't. So I appreciate that the actors did a really good job interpreting these scripts on the screen. But for me, as a data scientist, that's not very helpful. So I thought, OK, but I can't create a social network of the Star Wars characters and miss Chewbacca or R2-D2. So what I did, I actually decided to basically estimate how many times this character would have spoken if they have spoken in a script. So I did that by estimating, OK, how many times a character is mentioned in a scene, how does it compare with the number of times the character actually speaks in the scene. And I came up with some really, really complicated mathematics. And turns out, basically, characters are usually mentioned 2 times as much as they speak. So that allowed me to basically impute these characters that don't speak explicitly into the scene by looking at how many times they were mentioned. So good, I'm ready to go. Except, yeah, well, Chewbacca is happy because he got into the social network. Some characters didn't make it. So if you liked Ewoks, they don't speak in the scripts either, but I just didn't have enough patience to just get all of them in. So I'm sorry. And some characters messed up my implementation again, because if you have seen episode 7 of Star Wars, Luke Skywalker looks very dramatic here. They talk about him a lot, but he doesn't speak a single word. So he messed up my algorithms again. But in the end, I managed to get all the characters. But I ended up with a lot of strings that I thought were characters. So I thought, OK, so what can I actually do with this? How can I validate that something or someone is a character in Star Wars? Well, my theorem is that there is an API for everything. Similarly, like in R, there is a package for everything. There is an API for everything. So there is an API for Star Wars. And if you go to swappy.co, you get the Star Wars API. So I thought, OK, I can use this to validate my characters. I looked at the website. They have very nice documentation. They have wrappers for the API, things like R, etc. I thought, OK, maybe I should use just one of these. But then where's the fun in that? And to be honest, I didn't do this stuff in R. So all the code is actually very boring if you look at all the wrappers. So I will actually show you some of the code that I wrote for it, but it will be in F#, which is a functional programming language. It's statically typed, and it has some really, really cool features for working with data. And I will basically write part of my provider that will give me access to the API directly here, if my internet connection works. So because F# is a statically typed language, I will first create a type for my REST-based API. Let's call it a person, because I will get information on people. And the API returns a JSON. So I will create something called a JSON provider. And I will just give it the URL of the API. All right. And I am basically all set, because right now I can just create a function to get me all the information based on an ID. And the only thing I need to do is load the correct URL. And because F# is a statically typed language with type inference, I have to change the ID to a string. And now let's get a person called X. Let's get the first person. OK, I haven't done anything right now. I haven't run anything. I just wrote some code. And now if I do X dot, it immediately tells me what's in the JSON. I didn't run anything. What's happened? It's magic. And the great thing is, it also tells me the types of things. So for example, height is an integer. You can see it there in the pop-up thing. And gender is a string. Eye color is a string as well. I still haven't run anything. I don't know who this person is. And if I look at the name is, again, a string. That's really cool. The thing why I used F# for this is that it gives me access to everything. It infers the types. I can write my code. I can do anything cool with that. And I can run it afterwards, and I'm sure it will work, because it looked at the JSON format, it inferred everything. So I basically went on and created a wrapper for the whole thing, and it took me 67 lines. Most of them are not very interesting, basically just calling the JSON type provider. And now I have all the cool information about Star Wars characters. So let's actually run something. Let's download information on all the people. And what appeared down there is the F# REPL. OK, now I have information on all the 87 characters that are in the API. And I can find out all sorts of interesting information you always wanted to know about Star Wars characters, like what's the most common eye color. And the most common eye color among Star Wars characters is brown, because, for example, Han Solo has brown eyes. Yoda has brown eyes, in case you wondered. The second most common is blue, and the third most common color is yellow. So Darth Vader has yellow eyes. I'm not sure how they managed to find that out. And I can also validate all sorts of interesting information. For example, in the original New Hope, Star Wars Episode 4, Luke Skywalker wants to rescue Princess Leia, and he dresses as a stormtrooper. And he rushes into her cell, and she's like, aren't you a bit short for a stormtrooper? We can validate that. So let's look at Luke Skywalker. And Luke Skywalker, his height is 172 centimeters. I'm not sure how much that is in the imperial units. Sorry, I'm European. And I can look at the average height of a Star Wars character, not just stormtroopers, sorry. But the average height is 174 centimeters. So yes, Leia was right. Luke Skywalker is a bit short. We validated that. All right. So then I went on and did a pull request, and now F# wrapper is there on the Swappy website as well. So now I had all the scenes and all the characters extracted from that. I thought, OK, so what can I do next with the data? And then I saw a very cool analysis online done by Polygraph, where they looked at screenplays, and they extracted characters and looked at their gender and looked at how much men speak in films and how much women speak in films. And it was a bit depressing, because they looked at Disney films, and in most of the fairy tales, it's actually just male characters speaking all the time. So I thought, OK, let's have a look how it looks for Star Wars. And this is a graph starting from Episode 1 to Episode 7. And these are all characters that speak in at least 2 scenes and that have explicit name in the script. And you can see that it only improved a little in Episode 7, but in the original Star Wars, like 83% of all the characters speaking were male. So it looks like space is for men only still. And I'm sorry, I just looked at men versus everyone else, so I grouped women and robots. And I'm not sure who should I apologize to. So then I had all the data, and the first thing that everyone does when they have a data set is to visualize that. So finally, let's look at the whole Star Wars universe. Come on. Yes, it opened. So this is a D3 visualization of the Star Wars network. Ta-da! And I can move it around. It's a lot of fun for me to play with. So this is the network of the original Star Wars movie, Episode 4, New Hope. And you can see that there are a couple of major characters. They have fairly strong links between them. And then there are a couple of minor characters around. This little node that's not connected to anyone is a character that doesn't speak to anyone else in their scene, which is one of the Resistance pilots that appears there only in a cockpit and doesn't speak to anyone else. So this is how it compares to the first episode of the prequels, The Phantom Menace. And you can see, whoa, that's a huge network. Because for this one, there are like the major characters. They are fairly densely connected. But this, like, whoa, what's happening there? And this is how it compares to episode 7. You can see that there are quite a lot of characters, but definitely less than in the Phantom Menace. So can we quantify that, actually? How do the movies differ in numbers? And basically, my hidden goal was, let's prove that the prequels were rubbish. Using data science. So this is the size of the networks, just the number of characters that appear there. And as I said, these are characters that have explicit names in the scripts, so nothing like a stormtrooper, but Han Solo, Chewbacca, etc. And they have to speak in at least 2 scenes. And you can see that in episode 1, the number is the highest. Then in the original trilogy, which are these 3, it's a bit smaller. And then episode 7, it jumps up again. And to make it even more explicit, this is the number of characters per a minute of screen time. So in the episode 1 of the prequels, there are almost 1 character almost every 3 minutes. That's way too much. So what can we do next? I decided to look at some network characteristics. So the first one was density. If you have an example network like this, density basically just compares the number of connections that are in the network with the number of connections that could be in the network. This is how you do it mathematically. The interpretation in terms of the story is that a network is very dense. That means everyone is talking to everyone else. If it's very sparse, it means the characters just don't talk to each other. And this is how it looks for the movies. And again, for the 2 first movies in the prequels, they have the lowest density. That means they have way too many characters that don't talk to each other. And then the density is higher for all the subsequent episodes. And it was the highest for episode 6, maybe because I discarded all the Ewoks. Sorry again. So then I decided to look at their local structure. So I looked at the indicator called the clustering coefficient. So what it means is, it basically looks at if your friends know each other or not. So this green guy in the corner, he has 3 friends, and 2 of them don't know each other. And this guy, he has 3 friends again, but they do know each other. So the clustering coefficient basically quantifies that. You look at the number of neighbors and how many of your neighbors know each other. And in terms of the story, if a network has a very low clustering coefficient, it means it follows one character that talks to other characters, but these characters don't talk to each other. They don't know each other. They don't have any backstory. And if a network has a high clustering coefficient, that means everyone talks to everyone. Well, I'm sure you can imagine by now how it looks. It's the lowest for the prequels, and then it goes up in the other episodes. So the prequels were rubbish based on this as well, because there are just way too many characters that don't talk to each other. And then in episode 7, it dropped again. So I can't quantify that for the episode 8 because I don't have the screenplay yet. And then I decided to look at the most crucial question. So who is the most central in the Star Wars universe? So the most straightforward measure is the degree, where you basically just look at the number of neighbors. So this guy is very central because he knows 6 people. And this guy is less central because he knows only 3 nodes. So that's a very straightforward thing. And then I decided to compare that with something called Betweenness. And this measure tells you how in between other characters someone is. So if I look at this guy, well, and these 2 other guys, he's very crucial for them, because if they want to talk to each other, they have to go through the green guy. And if I take these 2 guys, the green guy is not that crucial for them because they have other ways of communicating as well. So this basically tells you how central a character is in the story, how much the character connects different communities. So this is how you compute it mathematically. But the crucial thing is that you have to compute the shortest paths between nodes, and that's quite a lot of work already. So The great thing in R is that there is a package for everything. So I used the iGraph package. And as I said, I was doing some of it in F#. So basically, I just called it from F#. And we have a type provider for that, like the JSON type provider I was showing you before. There is a type provider for R as well. So you just type R dot, and you get access to everything you have in your R installation. So that was easy. And this is how it looks for episode 7. So if I just look at the degree, the most central character is Poe Dameron, which is one of the resistance pilots. And then you have all the other characters. But you can see that the main characters are actually not there if you have seen episode 7. If you haven't, I'm sorry. But if you look at Betweenness, suddenly Kylo Ren is the second, and Rey is the third. So this measure captures much more how a character is crucial in the story, how the character connects different communities. So, but Poe is still the most central character there, so he's celebrating. And now you might ask, so who is the most central of the whole network? Well, before episode 7, it was this guy, Obi-Wan Kenobi. But then he died in episode 4, so he probably can't continue being the most central. So when I actually included episode 7, ta-da, Darth Vader still rules the galaxy. So, as Jared mentioned, everyone wants to talk to me about Star Wars. And actually, this is, well, I did a normal statistics PhD, but this is my most academically successful work, to be honest. Because I put all the networks in a JSON format on my GitHub with a permissive Creative Commons license. And turns out people are using these networks for education, to teach people network science as an example data set. And then they have a headache because they are trying to figure out how to actually cite a GitHub or my blog post in their academic papers. And this has been pretty successful. And it was also published in an actual paper magazine in Pour Science, which is a French version of the Scientific American. So I was pretty excited about that. They sent me a paper copy. And, well, I did this while I was in Cambridge. And when I actually read it, I don't speak any French, but I'm pretty sure this doesn't say Cambridge. So my takeaway message for you is to put your data out, because people will use them for their own means. They will get it wrong, but they will use them. And then it was useful for me as well, because back then I was doing cancer research, and I was reading a paper. And I looked at some of the figures there, and they were trying to predict oncogenes and tumor suppressor genes. And they were trying to predict a network between them. And then they had this figure there where they claimed that tumor suppressors and oncogenes have higher betweenness in their networks. I was like, betweenness? I know this from Star Wars. So I think there is a lot of value with playing with actual interpretable data sets, because sometimes you just run an algorithm that you don't really understand that well on your customer database or on some gene database. Something comes out, and you don't really understand the results. But in case of Star Wars, you probably do. So play with interpretable data sets, please. And if you want to talk about Star Wars or anything else, just find me later or ping me on Twitter or anything. And may the R be with you.